Okay. So what I'm going to do here is really what typically would happen. And that is you actually pass two numbers. So let's say int num n and int m, and here you return n plus m, which is really, again, typically what you would see if you have a function that adds numbers or multiplies numbers or does some sort of processing, data processing. Usually it kind of takes the input as a parameter and then it processes those kind of values. And of course, here you can say 200, 500, or you can say var1, var2. But for now, I'm going to start with 200, 500 like this directly. Let me make this smaller. Okay. So I'm going to start with main. So main is going to do jump and link to add two numbers. But as you probably are expecting, I mean, if you think about it for a few minutes, you will probably reach the conclusion that before we jump and link, we probably should put these two numbers in registers that this function expects them to be in. Because that's what we did when we returned the value. When we returned the value, we said this function is going to put the return value in v0, and this function who's calling add two nums is going to expect the return value to be in v0, and that's how you're kind of returning values. You're putting them in registers based on some sort of agreement. And the same thing actually happens here. Before you call this function, you need to put 200 and 500 in registers that this function expects them to be in. And those registers are between A0 and A4. The registers A0, A1, A2, A3. Actually, right now, I forgot if there's an A4. I think there is an A4, but let me open the simulator, make sure. Maybe we only have A3. I'm pretty sure we have A4, but let me open the simulator. Yeah, we don't have A4. So we only have from A0 to A3. I thought we have A4, but yeah, it's only from A0 to A3. And we can talk about what would happen if you want to kind of send more values, but let's skip this for now. Let's postpone that discussion. So the registers A0, A1, A2, and A3 are used to put arguments in. So this one is called an argument, and this one's called a parameter. Now, in many cases, or maybe I should say in most cases, we actually don't make the distinction. We just say arguments or parameters. But if you want to be precise, this is really a parameter, and this is an argument that you send to the parameter. So those A's from A0 to A3 are registers that you should use when you want to send arguments to the function. So before you jump and link to add two numbers, you want to put A0, or rather you want to put 200 in A0, and you want to put 500 in A1. Now, this function, that's what it's going to expect. So this is something that's very important. Let's make sure that we understand this. This function does not have to ask main, where do you want to put 200 and where do you want to put 500 so that I can process them? There's no such thing. This function expects this to be in A0 and this to be in A1. This is part of the rules. This is something that has to be, this is convention that needs to be followed. So it's the responsibility of main or any other function that's calling this function to put the right numbers in the right registers. And in this case, A0 has to have 200 and A1 should have 500 before we jump and link. That's how it works. So for the add to nums function, again, what this function is going to say or do is it'll say, okay, there are two parameters here and I'm going to add them. And it's going to say, okay, this first parameter has to be in A0. This one has to be in A1. So I'm going to just add A0 and A1 and I'm going to return the result. And I know that if I want to return something, I have to put it in V0. So simply, this function is going to say add V0, A0, A1. And it's going to just jump register RA. That's it. That's all that it needs to do. And of course, here for main, once we jump and link, we're going to put the result in var3. We can use T0 for var3. So I can say add T0, V0, and 0 here. And of course, I have to put 10 in V0 and do syscall. All right, do you have any questions about this? Okay. So if you have more than 4 parameters, then this is something that we really don't want to talk about. But just to give you a short answer, what happens is we put, the 5th and 6th and 7th arguments on the stack. And this function is going to bring them from the stack. So instead of putting them in other registers, we actually put them on the stack. And this register knows exactly where to bring them from in the stack. So it's really, we can do it, but I think there's other things that are actually more important that we have to discuss. But just in case you're wondering, can we send more than 5 values, more than 4 values? The answer is yes. You would put the first 4 in A0, A1, A2, A3, and you would put the rest on the stack in a place where this function really expects them to be in the stack. So it's, that problem is really not a big problem. So it's not a problem. Okay. So there is something that I need to tell you, and this one is more important, and that is we talked about V0, we talked about the A registers, but you need to know whether those registers are treated like a T register or like an S register. This is actually important because based on that, whether they're used as or they're treated as an S register or a T register, you're going to have to write code. I'll give you an example. Let's say, for example, you're going to say int var4 is equal to add two nums, and you say 200, 400. So in this case, this line has been translated to these 4 lines. Okay, so this line has been translated to these 4 lines. And right now you want to say, okay, now I want to translate this line. Now, the first question that you're going to think about is, what is in A0 after I call this function? The reason why you're interested in this answer to this question is because you'd like A0 to have the value 200, because when you make this function call, you would like A0 to contain 200 and A1 to contain 400. So you're interested in knowing whether A0 is going to stay 200 or whether it could potentially be changed. And this is really the same question that we're asking. It's the same question as asking, is this treated as a T register or as an S register? Because if it's treated as a T register, then there is no guarantee that after this function call, it'll have the same value, 200. If it's treated as an S register, then there's a guarantee. The reason why there's a guarantee is because add two numbers is not allowed to change A0 or A1 unless, it's preserved, just like, just like an S register. Does that make sense? Give me some reactions here. We need to know whether A0 could potentially be changed by this. Now, of course, add two numbers may have to change A0 and A1 because it may have to call another function. But really the question is it going to preserve it? Just like sometimes we have a function like this one, that needs to use an S0. I mean, that's okay. You may have a function that needs to use S0, but because it's going to preserve it, then we're not really worried. Main is not really worried about this function changing S0 because it'll have to preserve it and then bring it from the stack. So same goes to this one. If A0 is going to be used here and it's going to be preserved, then main is not really concerned about A0 being changed here because it'll be loaded, or the old value is going to be loaded, and to main, it's as if A0 hasn't been changed. Now, of course, we do want to use A0 and A1 when we call another function. So here, if this one is calling another function, let's say int, let's say just void, kind of random function that takes a value, int num, let's say it does nothing here. And let's say this is calling it, so it says random function, say for example, 100. This one is gonna require add two nums to put 100 in A0 and make the jump. Just like we put 200 in A0, this function has to put 100 in A0. So there are circumstances where this function will have to use A0 and A1. The question is it going to preserve it when it uses it? That's really the question. And the answer is it doesn't have to preserve it. So this function can actually overwrite A0 and A1 freely, just like T0 and T1. It's just an agreement, and that's the agreement. The agreement is this function can change A0, A1, A2 without worrying about anything. So what does that mean? It means that it's the responsibility of main to somehow kind of re-put this value 200 in A0. So let me show you an example of code that would be wrong. If you assume that A0 is not going to change, which is a wrong assumption, then you can say, okay, when I do jump and link add two nums for the second time, which is really here, I'm not going to put 200 in A0. I'm just going to put 400 in A1, because in A1 I have 500. That's not really what I want. I want 400. So I'm going to just say add immediate A1 0 500. So this would be wrong. The reason why this would be wrong is because we made the assumption that A0 was not changed when we call this function. And that's just a wrong assumption. We don't know what's going to happen to A0. A0 should be treated like a T0. So because of that, the correct answer to this code would be to load it. I mean, it's going to be Actually, simple solution would be to say I have to put 200 again. So it's the same line that you have here. You're going to make sure that you put 200 in A0 because this function add two nums may change A0. And in this case, actually, it will change A0 because it will have to put 100 in it. So I'm looking at some kind of code here, and I'm trying to think of like some examples that we can do together. Okay. Um, I guess before we do that, do you have any questions about anything kind of I said? We'll do examples if you don't have any questions. Let's open the simulator. I'm gonna do it in the simulator. And I think what we can do is we can stop the recording and start a new one.